Okay, so hello everyone, I am Tanisha Sabherwal, and the talk for today is the DEV-inci code for design. Meet Peter. Peter is a developer who does not really understand design because he thinks it's just another form of art which requires very aesthetic sense and it's very intuitive. However, when I tried to convince Peter that this is not exactly the case and that design does involve logic and science, he seemed a little bit angry. So I thought, why not take up the next 10 minutes in trying to convince Peter that design does have reasoning and it does involve logic. So, for starters, let us talk colors. Um, in the starting, I have a short task for you, and I need you to let me know that which among the two options is relatively easier to read. Now, according to me, for Peter and most of you, the answer would be that the lighter text on blue is relatively easier to read as compared to the darker text on blue. And mind you, I'm talking about most of you and not all. But wait, let's try another one. How about now? Again, according to me, I guess the answer would have been reversed in this case, that the darker on blue seems relatively much easier to read as compared to the lighter on blue. Now, why is that? The answer is as simple as it may sound. Context changes with the way I perceive things. And that's why I said most of you and not all. And that's because I perceive differently for different individual. And the whole idea here is about the context that you're trying to deliver to the user. The simplest example in this case would be when you try to enter from a brightly lit room to a dimly lit room, your eyes take some time to adjust to the surrounding. And that's the context that I'm talking about. To give you more story behind this whole thing, the first image, that is the one with the lighter background, was originally a part of an article written by an anonymous writer. uh, he says that the WCAG guidelines for color contrast is a myth because although the darker text on blue does pass the minimum color contrast ratio, it is not as readable as the lighter on blue, which does not. To which Joffrey replied with another article saying that this is not exactly the case, and it's not about the contrast ratio being at fault in this case, but more about the context that you're trying to deliver to the user. And just because you change the background color, the whole answer changes. So it's much more to that. And this has been raised time and again in the WCAG and is also part of the repository as an issue that this particular matrix color contrast ratio, which is 4.5 is to 1, isn't very comprehensive. If you see on the right hand side, you would notice that there are a set of color combinations which do pass the minimum color contrast needed, but they are not as readable as other color combinations which actually do not. So the comprehensive that I'm talking about is this particular matrix we get by luminance ratio. And luminance is a matrix that we measure from 0 to 1, 0 being black and 1 being white. It isn't very comprehensive enough because it does not include brightness and color difference, which are an essential part of color contrast, as is the luminance ratio. If you go on to read the official documentation of W3C techniques for accessibility evaluation and repair tools, you would notice that they mention something called better readability when the uh, background and the foreground colors uh, are past minimum brightness and color difference, which is 125 and 500 respectively. And this is particularly for number one, people with very high color contrast disabilities, and number two, when viewed in extremely dark or extremely light backgrounds. So the answer to the original question that we have, that why black on blue, although it does pass the minimum color contrast, it's not very readable, is just the fact that it does not pass the minimum brightness and color difference. And that's why when viewed in a lighter background, it is not as readable as some other options that are on a plate. And to give more support to my statement, if we take another color combination, another blue and white, which does pass all of these values, and all of a sudden you would see that it is indeed readable as compared to the other options that are there. So, yeah, Peter, it is about logic. It does involve some numbers and it does involve maths. It's not entirely aesthetic sense, but there's much more to it. But let's not stop it here. Let's talk about animations. When we talk about the motion system is a set of transitional patterns that help us navigate through an app. And these patterns are much more intuitive for us to have a seamless experience. And if you notice these animations, there's some sort of symmetry and there's some sort of harmony to it because all of these happen on a particular axis. In this example, the first one is along the x axis, the second one along the y axis, and the third one along the z axis. So it's all science, Peter. It's all science. There are a number of factors that affect these animations. The first one being timing. Timing plays a huge role when it comes to animations. You would have often observed that the exit animations are much smaller than the entry animations, and that is because you want to get out from a task super fast and hop on to the next one. The second one being dimensions. Sizing plays a huge role when it comes to animations. A larger object obviously takes larger time to animate as compared to a smaller object. And that's why the timing duration for a card animating is not the same as a button animating. The next being gravity. You would notice that why most of our UI components like drop down and accordions tend to navigate towards the bottom because that's where the gravity acts up. And the most interesting one, resistance. When we try to drag to refresh our social media screen, it goes back to the original position, and that's what is resistance. And if you go on to read about it, it's very interesting how these animations follow the 12 basic principles for it to be more realistic. And surprisingly, this was first pointed out by Disney animators in somewhere around 1930s when they were trying to create the animations much more realistic. If you go on to read about these 12 principles, you would be surprised to know that that's nothing but actual physics, the projectile that we learned in our school. And that's what should be included in our animations for it to be more realistic and more intuitive. And if you go on to have a look at the majority of design systems that we have that mention motion, although they've used different terminologies, the fundamentals remain the same. Focused versus expressive. That is designated to complete a specific task and the attention is towards some specific region, versus expressive, which basically attracts our attention, which adds more to our user experience, and it's a delight to see. So, animations are important for brand messaging just as typography and color. We often talk about type scaling as to how, when our font size increases, so does the expressiveness of the content that we're trying to deliver. And we've often seen this in jumbo headings, carousels, heroes, as compared to text with a smaller font, which is much more productive and which is much more for contextual information. The same scale is followed by motion system. That is, as we try to increase the duration of our animations, the expressiveness of the animations increases. That is, these animations basically attracts our attention and creates a very soothing experience while we navigate through an app, as compared to smaller during animations, which are much more productive and designated to complete a specific task, that is a task on a button or any input field. So these numbers that you usually get as a part of your animations, it's not something of random, and it's been well thought and on a scale. And it's very important that we realize that these numbers, when put, play a huge role. You would experience a different animation at somewhere around 200 milliseconds and something very different at 300 milliseconds. To add on more to it, the same applies to dynamic duration. There's some scaling both on the basis of the sizing of the function, sizing of the component versus the time taken for the component to animate. And that's the same that I mentioned previously, that dimension plays a huge role. As we try to increase the dimensions of our UI components, so does the duration of the animation that it takes. And it's as simple as a larger object might take longer time to move from point A to point B. And that's why larger UI components might take a larger time to animate. And that's what we need to set when we're trying to make animations. that a larger uh, UI component is given a duration which lies in a larger time span as compared to a smaller animation, which is basically a button. So yeah, Peter, I think Peter and most of you who might have thought that they can't really get their head around design and can't understand design might feel like a designer now because they finally cracked the Da Vinci Code for design. And I need to mention that this is also something that I came across very recently. And this is an interesting read to know that all the things that we get in a design files have an underlying story and underlying reasoning to it. And I think this particular topic has such a wide expanse, and we can just go on figuring out that why certain things behave like the way we are, and we are not able to figure out with our eyes. It has some inherent logic to it. So yeah, that was about it. If you know anything that has some logic to the design that you've seen around, just share with us in the sessions tab. Thank you so much.